I'm really glad to have you all back after this hurricane. I'm hoping by Monday we'll get back to in person. And I think by Monday everything around the Walker Hall building should be fine. I think everything is fine now, but I heard there are a lot of some maybe like a lot of cleanings and stuff. So I thought it's better we start with Zoom this week and then we resume on Monday. Okay. Today I would like to start with trigonometric substitutions. I started this, I think, the last day before the school was closed down, but I thought it wise to review it again. So people who weren't in class during that time could be able to understand and then finish everything up. So in this section, we are going to learn how to find the antiderivative of functions like, how do we find the antiderivative of function like this? That is what this section it's about. It's going to help us to find the antiderivative of functions in the radical expression. If we have functions like with this, we could be able to use the method of substitution to be able to do this, one. But for this, it's going to be a bit difficult because even if you use substitution to be u to be x squared plus 25 and you differentiate, you're still going to have x in there. And so it's going to be a bit cumbersome to do that. And so that is what we are going to learn how to be able to find the integral of functions like this. And so to do that, there are three main functions I would like to put across. So that is how we are going to, so that I will be able to learn how to integrate such functions. And so one of them is if we have functions in the radical sign like a squared minus u squared. The other one is also a squared plus u squared. And then u squared minus a squared. So here, where a is a constant. So when I mean a constant, it could be a number. So for example, when we look at this, we can see that a here is 5 because here a squared. So a here is what? 5. And then u is a function of x. So these are the main functions we are going to look at and how we are going to use trig substitutions to solve that. And so I want you to have these three functions in mind. And before that, let's try to remember some trig properties. So let's remember. We know that cos squared or cosine squared of theta plus sine squared of theta equals 1. You all remember this, right? And so from here, we can see that we can say cos squared of theta is the same as 1 minus sine squared of theta. And so we can see that cosine of theta is the same as square root of 1 minus sine squared of theta. And so if we have situations where, let's look at the first situation, where we have a squared minus u squared. So in this situation, we are going to replace u to be a sine of theta. I think it's very important to be able to write this. So if you have situations where a is a constant and then you have minus here and then u squared here, we are going to manipulate this and then represent u to be a sine of theta. So I think it's important to be able to write this in your notes. Let's look at the other situation too. The second one too is also if we have square root of a squared plus u squared, we are going to replace u to be a tan theta. This is because, remember from trig properties, that sec squared theta is equal to 1 plus tan squared theta. Okay, and so we can see that sec squared theta is equal to square root of 1 plus tan squared theta. You see, so here is plus, so you are trying to mimic something like this here. So you see, so this is just 1 squared. So we are going to represent u to be a tan theta. And then let's look at the last expression. So the last expression is when you have u squared minus a squared. So here we replace u to be a sec theta. Knowing this is very, very important because it's going to save you a lot of time in trying to find the antiderivative. So it's very good to be able to spot stuff like this and know what to do. Representing u with sec theta, it's the same thing as using the property here. So from here, we can see that tan squared theta is the same thing as sec squared theta minus 1. And so we can see that tan theta is equal to square root of sec squared theta minus 1. So these are the 3 main things that you need to know what to do. Before I start with an example, I want to be able to write out some guidelines. So these are the guidelines. So for you to find the antiderivative of some radical expressions, first and foremost, you have to be able to know which trig function to substitute. So you have to be able to know, look at the radical expression you've been given, Am I going to use sine theta, tan theta, or sec theta? You should be able to know which trig function to substitute. So I'll write this as identify which trig function to substitute. Are you going to use are you going to use sine theta, tan theta, or sec theta? The other one is that we need to rewrite the integral in terms of theta. And then the third is we need to simplify and then integrate. And then finally, because we rewrote everything in terms of theta, we have to substitute back from theta to x. So we'll be using a triangle. So I call that SOHCAHTOA. I believe most of you have heard about the SOHCAHTOA. So we are going to, when we are substituting back from theta to x, we are going to use this property. It's going to be very, very beneficial to us to do that. Now let's look at a quick example. Let's evaluate the integral. So let's see. Let's try to evaluate this integral here. If I want you to find antiderivative of this, how are you going to do that? So in this is the situation where applying trig subs is going to be very beneficial. Now look at this example here and tell me which of these three situations looks similar to this. Anybody wants to help us? Now I can rewrite this question as this. This can be written as 6 squared minus x squared dx. This is because we know 36 is the same thing as what? 6 squared. And so what are we going to use? So you can see from here that it looks like the first one because here the constant comes first and then the operation here is negative and then u. So you can see the constant comes first, the operation here is negative and then u. So we can see that here we are going to replace let x equals, remember here it says that a sine theta. So a sine theta. But what is our a? Here our a is 6. Is that okay? And so we are going to say x to be equal to 6 sine theta. Any questions so far? Good, Noah. Any questions so far? Do you all understand why we are using the first one and then how we are trying to change everything from x to theta? Do you all understand why we are going to substitute x to be 6 sine theta? Does any of you have any questions on that? Do you understand that? Okay, let's proceed. And so the guideline says that we should be able to identify which trig function to substitute. So in this expression, we've been able to identify the trig function. So we are going to use x to represent 6 sine of theta. The next one says that we should rewrite the integral in terms of theta. How do we do that? So we can see from here that we said x to be 6 sine theta. Okay, what is dx? If you differentiate this, what do you get? You are going to get 6 cos theta t theta. Correct? Okay, let's proceed. So now let's try to represent everything here from x to theta. So now we have our integral sign here. This is the radical sign. There is 6 squared. I write that here. Minus, we said our x to be 6 sine theta. And here is x squared. And so I have 6 sine theta all squared. Okay. And then here we have the x here. What did we find out for the x? We saw that the x is the same thing as what? 6 cos theta t theta. This is how we represented everything in terms of theta. So to go over again, the first thing you have to be able to know which trig function to use and then be very careful. It is a sine theta. So make sure that you write in terms of this way so that you don't say that your a is 36. Your A is not 36. So I try to let everything look like this one here. You see, it's A squared. So your A is 6 sine theta. And then now we represent everything in terms of x. And then I have this. Remember, here is what? The x. And so I differentiated this thing here. So in place of the x, I put in this thing here. Yeah. Now that we've been able to represent everything in terms of theta, we can now go ahead to simplify. Let's try to simplify. So now we have this. I have my integral sign here. This is the square root. And so this is 6 squared minus, this is the same thing as what? 6 squared sine squared theta times 6 cos theta d theta. Remember this thing here. It's like you are having x, y, all squared. This is the same thing as what? X squared, y squared. So that is what we just did. Okay, so now let's proceed. So here I could bring 6 squared out. I'll be left with what? 1 minus sine squared theta here. And then times 6 cos theta d theta. Remember, if you have A times B, this is the same thing as A, B. Properties of sets. Remember, this is multiplying this. And so we have the integral. So the square root of 6 squared is 6. So we have 6 here. And then we have square root of 1 minus sine squared theta here times 6 cos theta d theta. Okay, now that we have this, remember what we said here. Look at this property here. 1 minus sine squared theta is the same thing as what? Cos theta. 1 minus sine squared of theta, the square root of 1 minus sine squared of theta here is the same thing as what? Cos theta. So we could now change this thing here. So we have now 6 times 6 is 36. I could bring that out of the radical sign, out of the expression. So 36 here. And then this whole thing here is cos theta times, there is also a cos theta here, d theta. And now this gives you 36 integral of cos squared theta d theta. And then now we can see from here that we can now integrate. How can we integrate? We could be able to use what we learned in the previous section by using the half angle property. So from the half angle property, we know that cos squared theta is the same thing as half 1 plus cos 2 theta. We have learned this already. So we are just going to apply that. And so you can look through your notes, you'll be able to find this half angle property. So now, in place of cos squared theta, we can substitute this expression there. So we have 36 integral of 1 over 2, 1 plus cos 2 theta, and then d theta. And so now this gives us 18, 1 plus cos 2 theta, d theta. And then now we can now integrate this. Now this is easy to integrate. So we have 18. If you integrate whatever is here, this is the same thing as integrating 1 d theta plus integrating cos 2 theta d theta this way. And so this gives us 18. If you integrate 1 d theta, should give you theta. It's like integrating dx. It gives you x. Plus, here you can use u sub. If you find the antiderivative of that, you are going to get sine 2 theta divided by 2. Then we could put plus c here. Now the question is that, are we done? We are not done, but we are close. Now this is the integral, but remember our question was given to us in terms of x. You see, in terms of x and not in terms of theta. And so since we have theta here, we have to be able to now substitute everything back to x. That is what we need to do now. How do we do that? Remember, we said x to be 6 sine theta. You can see that from here. You see, we said x to be 6 sine theta. And so from here, we can see that that sine theta is the same thing as x over 6. And we can see that theta is sine inverse of x divided by 6. Okay, we've been able to fix this guy. How about this guy too? How do we go about that? So remember that we know that sine 2 theta is the same thing as what? 2 sine theta cos theta. So it's good to be able to know this property here, because here is sine 2 theta. So from here, we can see that sine theta is what? X over 6. And so we are going to make use of the SOHCAHTOA I mentioned earlier. So let's try to draw our right, and let's try to draw a right triangle here. And then let me put the angle here. Remember, here we can see that it's sine theta. And so sine theta, it means that so opposite over hypotenuse. And so if our angle is here, what is our opposite? So we are looking at, so here the opposite is x, and then the hypotenuse is 6. So the opposite is x, hypotenuse is 6. And then when we have this, we can be able to find this using Pythagoras theorem. So we know that 6 squared equals x squared. Let me put a here, plus a squared. And so you can see that a equals square root of what? 36 minus x squared. And so we can be able to now substitute that there. So here is 36 minus x squared. Okay, remember, what do we have? So we are trying to now represent the whole of this in terms of x. Let me write that here. So I have 18 theta plus sine 2 theta divided by 2 plus c. And we've already solved theta to be sine inverse of what? X over 6. And so now we can be able to rewrite this. So this is the same thing as what? 18 theta plus 9 sine 2 theta plus c. And what is our theta? Our theta is sine inverse of x plus 6. So this gives me 18 times sine inverse of x divided by 6 plus, this is our 9. We also said sine 2 theta can be written as 2 sine theta cos theta. So in place of sine 2 theta, I'm going to put 2 sine theta cos theta plus c. And so now everything should give you 18 sine inverse of x divided by 6 plus 18. What is sine theta? Sine theta is x over 6. And so 18 times x divided by 6. Cos theta. How do we get cos theta? So we can see from here that cos theta, SOHCAHTOA, adjacent over hypotenuse. And so what is the adjacent? The adjacent is square root of 36 minus x squared divided by the hypotenuse, which is what? 6. And so we try to put that here. So that gives you square root of 36 minus x squared divided by 6 plus c. And so the final answer is 18 sine inverse of x divided by 6 plus x Square root of 36 minus x squared divided by 2 plus c. Any questions so far? Okay. If no question, I want you to try this. I want you to try this. And so I'll be calling your name and then you tell me what you used for the substitution for x. And then you'll be telling me what you did next. And then we'll be doing that together. So I want you to try your hands on this example here. Okay, let's try to do that together. So now this can be written as x cubed 9 squared minus x squared dx. Now, Gabby, tell me, what did you use as your x? So what trig function did you use? So x equals Gabby, what did you use for your x? I can hear you. I think your mic is on, but like maybe your voice is not coming. Anybody else want to try? Jacob, what did you use for your x?
I got a 9 sine theta.
Okay. Jacob says he used x to be 9 sine theta. Meredith, do you agree with him?
I do.
Okay. Anybody else? Do you all agree that we should use x to be 9 sine theta?
Yeah, I agree.
Okay, good. Okay, if you all do agree, then what is the next step? The next step is to rewrite everything in terms of theta, correct? So how do we do that now? So I have my integral sign here. This is x cubed. I set x to be 9 sine theta. So in place of s cubed, I'm going to put 9 sine theta or cube. Okay? And then square root 9 squared minus 9 sine theta all squared. See? Now the only thing I'm left with is to now in place of dx, I need d theta. So it means I have to differentiate this. If you differentiate this, what do you get? Who wants to help us? David, if you differentiate, what do you get?
I got 9 cos theta.
Okay. So you're going to get 9 cos theta d
Theta.
theta. Good. And then let's now put that here. We're going to get 9 cos theta d theta. Okay? Now, whatever is left here is just algebra. So remember what I did the first time. I said if you have AB all squared is the same thing as A squared, B squared. This is just the properties of indices. So that's what we are going to do. So now we have the integral 9 cube sine cube theta, right? Just for this thing here. Okay? And then here is also 9 squared minus 9 squared sine squared theta times 9 cos theta d theta. Okay, now let's try to group like terms here. So now this gives us, we have 9 cube sine cube theta times square root. So now you can see 9 squared is common. I bring the 9 squared here. 1 minus sine squared theta here times 9 cos theta d theta. Okay. So now I have 9 cube sine cube theta times. Now be very careful. Like I did show you the properties of sets. If you have square root of AB, this is the same thing as square root of A times square root of B. Now, square root of 9 squared is 9. Be very careful so that you don't go and write 9 squared. So now this gives you 9 because square root of 9 squared, remember, square root of 9 squared, the square will cancel this. So you're going to get 9 square root of 1 minus sine squared theta here, okay, times 9 cos theta d theta. Now we can be able to see this is 9 squared times 9 times 9. You agree it's going to give you 9 power 5. Do you all agree with that? This is 9 cubed times 9 times 9. It's 9 power 5, right? And then integral of sine cube theta times. We remember we can represent the whole of this with what? Cos theta, like in our previous example. Cos theta times cos theta theta, because this 9 times 9 is 9 squared times 9 cubed is 9 power 5. When the bases are the same and they are multiplying, all we need to do is to add the exponents. So now we can see that our expression is now 9 power 5 integral of sine cube theta times cos squared theta d theta. Now, does this look familiar to you guys? Remember that the topic section 3.2 when we try to solve situations like this. So remember this is like odd power, and so we want to split that up. So we have 9 power 5 integral of, now this sine cube theta can be written as sine squared theta times sine theta times cos theta d theta. And so when we do that, we can say that we can use u subs to solve this. Let u to be sine theta. If u is sine theta, what is du? What is du? Mina, what is du?
Negative sine theta d theta.
Good. So negative. No, let me use u to be cos theta. And so the u will be negative sine theta d theta. So then that way we can see that here we have 9 power 5 integral. Remember, we said that, let me write that one here. We know that sine squared theta is the same thing as what? 1 minus cos squared theta. We know this already. And so we can see from here that 9 power 5 integral. So in place of sine squared theta, we have 1 minus cos squared theta times this cos theta. And then we are going to replace this sine theta and then this d theta with negative du. Is that okay? I think here is cos squared theta. Remember, here is cos squared theta. So it's cos squared theta. I just split this thing up here. Oh, it's right deep. Okay. So now we're going to replace this sine theta with the theta here. So now this implies that negative du equals sine theta d theta. That is what we are going to replace now. And this gives you minus du. And so it gives us minus 9 power 5 integral of what? 1 minus cos squared theta times cos squared theta times du. Remember, we said u to be cos theta, and so this gives you minus 9 power 5 integral of what? 1 minus u squared times u squared du. Now this gives you minus 9 power 5, the integral of u squared minus u power 4 all du. And then now we can find the integral of that. If you find the integral of this, you're going to get negative 9 power 5 u cubed divided by 3 minus u5 divided by 5 plus c. And then now, what is our u? We said our u to be cos theta. And so negative 9 power 5 should give us cos cubed theta divided by 3 minus cos to the 5th of theta divided by 5 plus c. Okay, let's try to expand this thing here. Or we could decide to leave it like that and then simplify. And so we have this here. Are we done? No, we are left with the final step. So we said x to be 9 sine theta. And so from here, we can see that sine theta is x divided by 9. Do you all agree with that? And so let's draw our triangle. My triangle doesn't look nice. Okay, and let me put theta here. So we are going to use the SOHCAHTOA. So sine opposite over hypotenuse. So if your angle is here, so here is what? X, here is 9. And then if you use the same thing as we did in the previous example, by using the Pythagoras theorem, you are going to have 9 squared equals x squared plus a squared, or b squared, or anything, whatever is here. And so you're going to get a squared equals 9 squared minus x squared. And so a equals square root of 9 squared minus x squared. And then you just substitute. So let's do that. So we have, here is what? 9 squared minus x squared. And so remember, we have negative 9 power 5 multiplying cos cube theta divided by 3 minus cos to the 5th of theta divided by 5 plus c. And so what is cos theta? Cos theta is adjacent over hypotenuse. And so that should give you 9 squared is 81. 81 minus x squared divided by 9. And then we just try to replace that here. So then that gives us minus 9 to the fifth minus 9 to the fifth, and then, or if you want, we can try to even expand first so that we don't need to rewrite a lot. So if we expand, we are going to get minus 9 to the fifth divided by 3 times cos cube theta plus 9 to the fifth divided by 5 cos to the fifth of theta plus c. All I did was that I tried to distribute this times this times that. That is, remember, there is negative. So here is negative, and then here's on would be positive. And then I could rewrite this as 9 to the fifth divided by 5 cos to the fifth of theta minus 9 to the fifth divided by 3 cos cube theta. Now we can replace cos theta. So now we have 9 to the fifth divided by 5 square root of 81 minus x squared divided by 9 all power 5. Okay? Minus 9 to the fifth divided by 3 square root of 81 minus x squared all divided by 9 all power 3. And so when we have this, you can simplify. If you simplify, this should give you 9 to the fifth divided by 5 times 81 minus x squared square root of that to the fifth divided by 9 to the fifth. Okay? Minus 9 to the fifth divided by 3 square root of 81 minus x squared all to the third divided by 9 to the third. And so this gives you, you can see this will cancel that. So that gives you 1 over 5. And then (81 minus x squared) 5 over 2. And then minus this gives you 9 squared over 3. And then we have 81 minus x squared 3 over 2. Let's see. Any questions? Any questions? What happened to the square that was on the course? Okay, let's get here. Okay, Noah, So this is the square here. And so we split this one here to be sine squared sine, okay? And then cos squared theta. And then we said u to be cos theta, and then the u is this. Okay, so this sine squared theta can be written as 1 minus cos squared theta. Now, we can also see that this cos squared theta is here. And then we represent sine theta d theta with negative du. Is that your question, Noah? Okay, good. Have a great day. Mary, do you have any question?
No, I don't. Thank you.
Okay, I'll see you guys tomorrow. Do have a great day.